Okay, the first problem on the test study guide, area of a circle is 36 pi square inches. So if we focus on those words, the area of a circle, that's pi r squared, equals 36 pi. That gets us to an equation that allows us to figure out what the radius is. The directions say to find the diameter of the circle, and we know the diameter of a circle is equal to 2 times the radius of the circle. So if I can figure out the radius, I simply need to double it to find the diameter. In order to find the radius here, pi r squared equals 36 pi. The pi's cancel if we divide both sides by pi. And if r squared equals 36, r would have to be 6, because 6 times 6 equals 36. Once I know that r is equal to 6, I simply go right there, change that r to a 6. And d is equal to 12, and the unit is square inches up there, so the diameter is going to be in inches. Number 2, what fraction of 60 is 24? They are actually requesting here a fraction. Anytime there's a fraction of, that means multiplication, so fraction of 60 is 24. So of means multiplication, is means equals, 60 and 24, the number is 60 and 24. What fraction is the unknown? I prefer looking at it like this, 60f equals 24. I just think that's a nicer look in my opinion. So if 60f equals 24, we divide both sides by 60. Always, whatever the letter is, always divide by the number in front of that letter. And it is requesting a fraction, so I do want to leave it as a fraction. I do want to reduce as much as possible, both 24 and 60 divided by 12. So 2/5 is the correct reduced fraction for that one. Number 3 is function notation, and this is really simple. As far as problems on the test, it's probably one of the easier ones. All function notation problem is, it's telling us to evaluate this expression when x equals that number. So to do this, I simply take that expression and I change x into a 3, and that's it. So x plus 7 is the expression, change x to 3, 3 plus 7 is 10. Same deal for number 4. We're trying to evaluate this expression when x equals -2. So we take this expression, 3 times x plus 1, we're changing x to a -2. 3 times -2 is -6, -6 plus 1 is -5. So those two problems in a row, 14 points of your test, really basic. Number 5, solving equations. We've gotten much more complicated equations than this recently, so hopefully this should be pretty straightforward. If I have 3x minus 7 equals 5, my goal here, since everything's simplified as much as possible already, is to get x isolated from the numbers. This has an x, this doesn't, so I'm going to move the 7 over to this side. Remembering when we move across the equal sign, we change the sign. 3x is left on the left-hand side. 5 and 7 both positive, add together to make 12. Then I have 3x equals, so we want to divide by 3 to get x equals. We're required to divide both sides by 3. 12 divided by 3 is equal to 4, which is the correct answer. Number 6, a decimal equation. The only thing maybe makes this more complicated is the decimals. We have 2 decimal places, 1 decimal place, 2 decimal places. I'm going to add a 0 to the back of that one to create 2 decimal places. And once everything has the same number of decimal places, then we simply take out the decimals, leaving whatever's left over. So this is going to be 7x. This is going to be minus 40. This is going to be equal to 352. And now it's the same difficulty problem the last one was. This has an x, these two don't. I want to get these together, so I'm going to move the 40 over here. It's moving across the equal sign, so I change its sign. 352 plus 40 is 392. Then we divide both sides by 7. Get x equals 56. Number 7. This time, the only difference between this one and the previous two is that we have like terms happening here. So 5y, 3y minus 6 equals 7 plus 6y minus 2. Alright, so if you look at what's highlighted in blue, of course the equal sign, let's start there. The equal sign's right here. I'm going to just bring that down. I've got the left-hand side of the equal sign I want to simplify as much as possible. And keep in mind there is a 1 in front of that y. Sometimes at this juncture in your algebra career, you might want to put extra coefficients there if they're not shown, just to remember they're there. All three of these have a y, so I'm going to create a y term off of these. 5 minus 1 plus 3 makes positive 7. And then minus 6, nothing's happening because there's no like terms with 6. Over on the right-hand side, 7 and negative 2. When we're deciding whether I should add or subtract, I look at the signs of each object. This 7 is positive, this 2 is negative. Those signs are different, so I subtract. 7 is bigger than 2, it's positive, so it should be positive 5. 6y has no like terms, nothing happens to it. So treat that problem number 7 first off as a simplification problem, add like terms. Next, we want to get y's on one side, numbers on the other, and this y term has a smaller coefficient than that y term, so that's the one I would move. So plus 6y moves over here, becomes minus 6y. It moves across the equal sign, so we change its sign. And since I got y's on this side, I'm going to get my numbers on that side, so minus 6 has to move over, becomes positive 6. Again, it moves across the equal sign and changes signs. 7y minus 6y makes 1y. 5 plus 6 makes 11. At this point, if there were a number in front of y, there's a 1, but we don't have to write it. If there were a number in front of y, I'd divide by it, but in this case I don't have to. The answer is immediately right there. But again, on the test, there might be a situation where there's a number in front of y, just divide by that number. Number 8, simplify. We're multiplying letters, and the rule of multiplication of letters is x to the m times x to the n equals x to the m plus n. We're doing addition of powers, but we're continuing to have a multiplication problem. So what I got to look at here is things of the same type affect each other. So m affects m, affects m, affects m, and y affects y, affects y. So if I deal with the m's first, the powers on m are 3, 1, 1, and 1. Hardest part is right. 3 plus 1 plus 1 plus 1. And for y, the powers are 2, 1, and 3. So the end result, 3 plus 1 plus 1 plus 1 is 6. The end result for y, 2 plus 1 plus 3 is 6. Notice m to the 6 times y to the 6. I am adding the powers, but I'm still multiplying the letters in my final answer here. So be careful that we do write it properly. Number 9, simplify by adding like terms. When we're comparing like terms, what we're looking for is the same letters raised to the same powers. So if I focus first of all on this 3xy squared term, whenever I do like terms, I always do this. I just take the first term and I compare it to everything else to see if it's a like term with anything else. X to the first, x squared different, x squared different, x to the first same, y squared same, so these two are like terms. Notice there is no number in front of x, y squared, so I'm going to put a 1 there because just remember there's a number there. There's always numbers in front of every letter object. Looking at my next term, negative 2x squared y, comparing x squared, y, y, so those are like terms also. And once again, there is no number in front of x squared y, so I'm going to put a 1 in front of it to remember there's 1 there. And then adding and subtracting is based on signs at this point. We're just adding and subtracting the numbers in front. So for the blue highlighted parts, I got a positive 3 and a positive 1, both positive, add to make positive 4. The powers do not change on my letters. What made them the same was x, y squared, that's what goes on the answer. The only thing that changes is the number in front. 3 plus 1 makes 4. Looking at my y terms, I got negative 2 and positive 1. Those signs are different, so I subtract. What made them the same was x squared y, so x squared y goes on it. 2 is bigger than 1, it's negative, so I'm going to get a minus on that one. That's as much as I can possibly do to that problem. These powers don't match, these powers don't match, so they're not like terms. Subtraction requires like terms, so you stop right there. Number 10, use the distributive property to expand. That simply means that we want to take this outside object here and multiply it times the first object and the second object in the parentheses. Keeping in mind that when I multiply, signs are involved and I have to account for that. And notice that we're multiplying letters, so we're going to be using that same power rule we used a moment ago, which was x to the m times x to the n equals x to the m plus n. If the bases match, we get that same base, we add the powers. So when I multiply this term times this term, I've got an x times an x. The rule tells me to add the powers. 3 plus 2 is 5. I got y times no other y, so nothing happens to y, it stays y. It's positive because both objects are positive. When I do this times this, positive times negative makes a negative, so I'm going to go to put a minus sign. X times x, we add the powers. There's a 1 inside. 3 plus 1 is 4. Y times y, I add the powers. 1 outside, 1 inside makes 2. And z times no other z's, nothing happens to z, it just stays z. So you get two objects. Object 1 is the product of these two guys. Object 2 is the product of these two guys. I'm expecting 1x, 1y, 1x, 1y, 1z. One of each type of letter in each term. So whenever pluses and minuses occur, that red term is a term, one of each letter. The blue term is a term, one of each letter. Correct signs based on multiplication rules. That type of stuff is the things that people tend to mess up on. So be careful that you really focus on the properties involved in that problem. Number 11, evaluate p times a minus xp times negative a. So I've got p times a minus x times p times negative a. Alright, and we do know that p is equal to negative 3, a is equal to positive 2, and x is equal to 5. So this is the type of problem where they give us all the information we need to do it, we simply have to do it correctly. So if I take my structure that I have up there, p is being multiplied by a, so here's p being multiplied by a. Then there's a minus sign that's just part of the expression, and then x is being multiplied by p, which is being multiplied by negative a. Again, that minus sign is part of it, but these things are being multiplied. P parentheses is multiplication. A's sign is being changed by that minus sign. And if I start throwing in numbers where they belong, p belongs right here, a belongs right here, x belongs right here, p belongs right here, and a is 2, and minus a then would be minus 2. Alright, so first off, substitute everything in. Product minus product is what's happening. I've got product minus product here. And then I am going to evaluate by the order of operations. This product has to happen, and this product has to happen before I add or subtract. And I don't know if I should add or subtract until I actually get the numbers evaluated here. So if I start with this product, 3 times 2 is 6, and 1 negative makes it negative 6. The second product, 5 times 3 times 2 is 30, and 1, 2, 3 minuses makes it negative 30, but it's in the subtraction sense here, so it's actually minus 30. So again, this is subtraction, it's still subtraction. If there were the right number of negatives, it could change to addition. It will not change to multiplication. All right, so get a product, get the right addition or subtraction sign there based on 1, 2, 3 negatives, odd, negative. If this was a negative 5, it'd be plus 30. Once you get both numbers with the correct signs, these numbers have the same sign, so I add them together. 30 is bigger, so it's negative. So negative 36 is the answer to that one. Number 12, simplify negative 3 parentheses negative 6 plus 5 and parentheses times negative 4 minus absolute value negative 4 plus 1. A couple things going on here. First thing I notice is I've got a object in parentheses, so I've got to deal with that before I would deal with anything else. This times this times this. Once I get that down to a single number, then I'm going to multiply all that stuff. I have an expression inside absolute value bars that has to be evaluated before the absolute value bars occur, so I want to do that also. So in my first step, I'm just going to write negative 3, parentheses. Negative 6 plus 5 is negative 1. Subtraction because the signs are different. Negative because 6 is bigger. Times negative 4. So all three of these objects are being multiplied. When I modify that object to what it is simplest, it's still all being multiplied. Then there's a minus sign in my problem. It's just part of the problem. There's absolute value bars in my problem, which is part of the problem. And then negative 4 minus 1, those signs are the same, so I add them together, and 4 is bigger than 1, so it's negative 5 inside the bars. Next thing I'm going to do is I'm going to go ahead and multiply all this stuff, and I'm going to deal with the absolute value of this stuff here. The minus sign separates these two objects, so this is kind of like a parentheses rule, this is kind of like a multiplication rule. In the order of operations, they're in different places, but Pluses and minuses separate objects. So you get a minus or a plus, you can do this and that at the same time with no harm. 3 times 1 times 4 makes 12, and 1, 2, 3 minuses makes it negative. The absolute value of negative 5 is positive 5, and the minus sign occurs after that. So one tendency students have, they see minus, minus, they immediately go plus all the time. Absolute value of negative 5 is positive 5. The minus sign occurs after the absolute value of ours occurs. So be careful that you do that appropriately. And then again, you're to a point now where it's either addition or subtraction based on signs. The signs are the same, so I add them together. 12 is bigger, so it's negative. Number 13, find the area of this figure. The easiest formula for area of a trapezoid, that's what this is. One pair of parallel sides makes a trapezoid. I know it's parallel because corners that look square are square. So those are both right angles, which makes these parallel to each other. Area of a trapezoid is 1/2 times base 1 plus base 2 times height. And it looks like a complicated formula, but it's just like the area formula for a triangle. So if you look at the area formula for a triangle, its area is 1/2 times base times height. Trapezoid has 2 bases, so we have to add those together. So for me, if I'm doing a trapezoid area problem, my problem looks like this on my paper. Area equals 1/2, and I'm looking for 2 numbers. The number that goes there is the sum of the bases. 8 plus 14 is 22. The number that goes there is height. Height is how far apart the bases are. Very easy to find those 2 numbers without too much difficulty. 1/2 times 22 is 11. 11 times 18 is 198. Unit of length is miles, so it's going to be miles squared. It will be a trapezoid on the test, and that formula will be available to you. The other option for a trapezoid, if you don't like that one, is if I were to draw a vertical line straight down from here to here. You break it into a rectangle on the right, which is 8 by 18, and that's 8 right there, so that means this is 6 right here, and this is 18 right here. So you got a triangle, 1/2 times 6 times 18 for the triangle, which would be 3 times 18, which is 54 for this part. And this part is a rectangle. 8 times 18 is 144 for this part. Add together these 2 areas and you get 198 also. Again, there's nothing easier than the trapezoid area formula. This is not that terribly difficult either, but I'd go that route myself. Number 14, find x. This I would call the easiest problem on the test. These are equal, so these are equal. Please don't miss that problem. It'll be just like that on the test. I'm going to give you a different number here. These angles might be different, but these will be the same. 40, 40, 100, 45, 45, 90, whatever. But these will match, so these are equal to each other. Number 15. A base of a right prism is the isosceles triangle shown. The height of the prism is 10 centimeters. Find the volume of the right prism. So the directions say to find the volume of the right prism. And the volume formula for the volume of a right prism is area of base times height. Area of base comes from the base, and height comes from the 3-dimensional picture, which I don't have a 3-dimensional picture, so therefore it comes from the words. The height of the prism is 10 centimeters. So h equals 10. I've already got that figured out. As far as b is concerned, I look at the figure. It's a triangle. The area formula for triangle is 1/2 times the base of the triangle times the height of the triangle. That's 6 times 8, which equals 48. So the area of the base is 48. On the test, it will be an isosceles triangle. Just like that, you'll get the base and the height, the 2 numbers you need for the area. So area formula for a triangle will be there. The height of the prism will be right there in the words. It might not be right at that specific spot, but it'll be in the sentence where it says the height of the prism is this. You find both of these numbers. Volume is simply the product of those 2 numbers. So volume equals 48 times 10, which is 480. Unit of length is centimeters, so that's going to be centimeters